Question 1. The Big Bang Theory, and what is it?
The idea that the universe began as just a single point, then expanded and stretched to grow as large as it is right now. And it's still expanding as we speak. The Big Bang was the moment 13.8 billion years ago, when the universe began as a tiny little fireball that exploded.
The universe takes shape. After inflation, 1/1,000,000th of a second after the Big Bang, the universe continues to expand, but not nearly as quickly. As it expands, it becomes less dense and cools. This most basic force in nature becomes distinct. First, gravity and electromagnetic forces. But a second, the universe is made up of fundamental particles and energy, quarks, electrons, protons, neutrons, and less familiar types. These particles smash together to form protons and neutrons. Formation of the basic elements. Protons and neutrons come together to form the nuclei of simple elements, hydrogen, helium, and lithium. It will take another 300,000 years for electrons to be captured into orbits around these nuclei to form stable atoms. The radiation era. The first major era in the history of the universe is one of which most of the energy is in the form of radiation. Different wavelengths of light, X-rays, radio waves, and ultraviolet rays. This energy is remnant of the primordial fireball, and as the universe expands, the waves of radiation are stretched and diluted until today. They make up the faint glow of microwaves, which bathe the entire universe. Birth of stars and galaxies. Gravity amplifies slight irregularities in the density of primordial gas. Even as the universe continues to expand rapidly, pockets of gas become more and more dense. Stars ignite within these pockets, and groups of billions of stars become the earliest galaxies. This point is still perhaps 12 to 15 billion years before the present. Many scientists have made contributions to the Big Bang Theory over the years, but two scientists in particular made major contributions. Those are George Lemaitre, the original man who formulated the modern Big Bang Theory, and Albert Einstein, who made the contributions to the Big Bang Theory through his theory of relativity, which reinforced the modern-day Big Bang Theory.
The three main lines of evidence that support the Big Bang Theory are the redshift of light, cosmic background microwave radiation, and the abundance of elements.
The cosmic microwave background, CMB, is a remnant radiation from the Big Bang, or the beginning of the universe. According to the idea, the universe was born with rapid inflation, expansion, and cooling. The universe is still expanding. The pace of expansion varies depending on where you look. The CBM is simply the residual heat from the Big Bang.
In 1924, Edwin Hubble figured out that these galaxies are actually outside the Milky Way. He observes a special type of variable star that has a direct relationship between its energy output and the time it takes pulse and brightness. By finding these variables and stars in other galaxies, he was able to calculate how far away they were. Hubble discovered that all these galaxies are outside our own Milky Way, millions of light years away.
Continuing on that, if these galaxies are far away and moving quickly away from us, this suggests that the entire universe must have been located in a single point billion of years ago. I would say this evidence is accurate, as Edwin Hubble was a trusted American astronomer.